Good morning, students. Today in this session I am going to explain you how to calculate arithmetic mean by discrete series. Already we have done the calculation of mean by individual series in my previous video. So today let's see how we can calculate mean by discrete series. So children, when we talk about the discrete series, then discrete series we do not have any class interval under this. And this discrete series is also known by the name of frequency array. So there are three methods of calculating mean by discrete series, as you all can see. The first one is direct method, then shortcut method, and then the third one is step deviation method. Now we will be taking each method one by one. Before that, let's see what is the formula for each method. If we go with the direct method, the formula goes like this. This is the sign of arithmetic mean equals to sigma fx, where f is the, you all know, is the frequency, right? And when we talk about the x is the, that is the number of items in the series. And again, upon sigma f is frequency. And when we talk about shortcut method formula says, again, arithmetic mean equals to a is assumed mean. Already we have done in the shortcut method, that is in the individual series, plus sigma f, again frequency. D is deviation. You all are familiar with the deviation. You all have done deviation in the individual series also, upon sigma f. Now this is the new method which we will be doing in this discrete series, that is step deviation method, and the formula goes like this. Arithmetic mean equals to a is again an assumed mean, plus sigma f d, and there is a small I, if you all can see on the d, this is a sign of deviation, upon sigma f into c. Children, this c is a common factor which we will take out when we will doing the step deviation method. So let's begin. We'll begin with the first method, that is discrete method. Under discrete method, direct method. So children, I have taken one example over here, that is the wages and the number of workers. So the wages is 10, 20, 30, 40, 50, and the number of workers are 4, 5, 3, 2, 5. And we have to take out mean by direct method. Now for this, a table has been drawn, you all can see over here, and on the table on one side we have x, that is the wages, then we have a frequency, number of workers, and then we will take out fx because we are doing by direct method, and a formula says sigma fx upon sigma f. So children, x we have written 10, 20, 30, 40 and 50, frequency again 4, 5, 3, 2 and 5, and fx means what we are supposed to do, we have to multiply this frequency from the x. So that is what we have done. 4 into 10, 40, then 5 into 20, 100, 3 into 30, 90, 2 into 40, 80, and 5 into 50, 250. And then what you have to do, you have to add all of them and you will get the, after addition, the addition it comes to 560. So your sigma fx is 560, and your sigma f, add 4, 5, 3, 2, 9, 2, 5, it comes to 19. Now we'll plot these values into the formula. The formula, that is sigma fx upon sigma f. So 560 upon 90, and when we calculate 560 from 19, that is we divide, we get 29.47, that is the mean. So children, this is how we are going to calculate mean by the direct method. Now let's see how we can calculate mean by the shortcut method. So for the shortcut method, if you see over here, again we have taken one example, and the example is same because we'll see that whether we calculate mean by the direct method or we calculate by the shortcut method or by step deviation method, the mean has to be same. It cannot be changed if let's say the calculation is done with the same figures. So again we have taken the same figures, that is wages 10, 20, 30, 40, 50, and then we have number of workers, that is if you see 4, 5, 3, 2, 5, and let's see how we can calculate shortcut method by shortcut method. Again if you see the table, we have drawn a table children over here. We have taken x, that is wages, Then we have taken frequency, that is number of workers. Now in this, if you remember, the formula says A plus sigma FD. So you have to take out deviation. And you know very well how we take out deviation because we have done previously also. But still, for deviation, you have to do what? You have to assume a number. But that number has to be assumed from X. Never assume number from F. Remember this thing. Children, they do a lot of mistakes. What they do, they assume from F. Then it will be wrong, children. You have to assume from X. So as I told you, you can assume a number which is a center number or any number divisible by 2. So let's say I have assumed 30 being a center number. 10, 20, 30, 50, 40, 30. So I have assumed 30 to be as a center number. So first we'll take out a deviation. So for taking out deviation, what you have to do? See, I have written over here X minus A. That means that from the X, the assumed number has to be minus. So 10 minus 30, that comes to minus 20. Then 20 minus 5, that comes to, 20 minus 30, that comes to minus 10. And then you have 30 minus 30, that comes to 0, right? And then 40 minus 30 plus 10 and 50 minus 30 plus 20. Now you have taken out deviation, but the formula says you need to find sigma FD. So you have to find FD first. You have F, sigma F. Frequency, you have total and you got it 19. So what we'll do, we'll find out FD. So FD, what you will do, you will take frequency F and D. Deviation kya nikla? Deviation is minus 20. So children, 4 into minus 20, that comes to, if you see, it is minus 80. Then 4 into minus 10, that comes to minus 50. Then 3 into 0, 3 into 0, 0. Then 2 into plus 10, that comes to 20. And then 5 into 20, that comes to 100. Now what you have to do, you have to add minus together and plus together. So if we add minus together, we get minus 30. And if we add plus together, that is 20 and 100, we get 120. So children, 130 minus 120. So minus 130 minus plus 120. So it comes to minus 10. So your sigma FD is minus 10. Now what you can do, you can plot these figures into formula. A plus sigma FD upon sigma F. Your A is what? We assume 30. So 30 plus sigma FD is how much? Minus 10. So minus 10 upon 19 because 19 is sigma F. So that comes to 30 minus 10 upon 19. And when you calculate it, you will find that 30 minus 0.53 comes to 29.47. So children, see, this is the same mean which we got when we calculated by the direct method. Now the next is the step deviation method. Now when we talk about step deviation method, again we have taken one example over here with the wages to be as 10, 20, 30, 40 and 50 and number of workers 4, 5, 3, 2 and 5. Now if you see, there is a certain changes in this table. We have 1, 2, 3, 4, 5 column. On the first column, we have taken X, that is wages. Second, we have taken frequency, number of workers. Then we have to take out deviation. For deviation, you have to assume one number from this X. And then you have to find out C. Right? Now, this is new. This I'll tell you as we will be doing it. And then FD, that is the deviation. So, children, we have written X, 10, 20, 30, 40, 50. Frequency to be as 4, 5, 3, 2, 5. Now deviation, as I told you, we have assumed 30 to be as a assumed number. So what we will be doing? 10 minus 30, that comes to minus 20. Then 20 minus 30, minus 10. Then 30 minus 30, 0. Then 40 minus 30, plus 10. And 50 minus 30, plus 20. Now the main thing, that is C. So children, C is a common factor. C means a common factor, a factor by which all these number, the deviation number can be divided. So if you see, the common factor among them is what? 10. 10 to the 20, 10 1 the 10, 10 1 the 10 to the 20. So 10 is a common factor. So what we have done? See, to take out a deviation, X minus A. X minus A is how much you got? Minus 20 upon C. Your C is what? Common factor 10. So minus 20 divided by 10, that comes to 2. Then you have minus 10. Minus 10 divided by common factor 10 comes to 1. Then 0 divided by 10, obviously 0. Then plus 10 divided by a common factor plus 10, that comes to 1. And plus 20 divided by 10, that comes to 2. Right? Now you will find out f d I. So for this, what you have to do, you have to take frequency, that is 4. And your deviation came what? That is 2. So 4 into 2, that is minus 2. This is minus 2. So 4 into minus 2 comes to minus 8. 5 into minus 1 comes to minus 5. Then 3 zeros are 0. Then 2 into 1 is 2. And 5 into 2 is 10. Now what you will do again? Minus 8 minus 5 will plus together. That comes to 13. And 2 and 10 to be plus together. That comes to 12. So children, your sigma f d I comes to minus 1. Now we'll plot again into the formula. Formula goes like this. Arithmetic mean equals to A plus A is assumed mean, sigma f di upon sigma f. Sigma f you have taken out when you have added all the frequency. Sigma f di is minus 1 and C is a common factor which is 10. So children, assumed 30 plus minus 1 upon 19 into 10 being a common factor. So that comes to 30 plus minus minus. So if 1 minus 1 divided by 19, that comes to 0.053 into 10. And arithmetic mean equals to 30 minus 0.53. And when you minus, so arithmetic mean is 29.47, which is exactly the same which we were able to calculate by direct method, by shortcut method, and by step deviation method. So children, this shows that when we take out or when we calculate mean by any method, or if you assume any of the number from the x, your answer has to be same. Provided if you have taken a different example for doing this, then it will change. But if it is same, then you can see if you find that somewhere you are facing a problem or you want to find out whether your answer is correct or not, you can do the same by the direct method and you will come to know if the answer comes the same. So it is correct. If it is not coming, then somewhere check your calculation once again. So children, this is how we can calculate arithmetic mean by discrete series under 3 different methods, that is direct method, then shortcut method and step deviation method.